Hi everyone, welcome to RoshChem summary videos. In this video, I'm summarizing the lesson polymers. So what are polymers? So polymers are large molecules made from small molecules called monomers. And there are two main types of polymerization where you put the monomers together. So one is addition polymerization and other one is condensation polymerization. So now we will go through addition polymerization. So in addition polymerization, an addition reaction is happening where the monomers are added by addition reaction. So we know in addition reactions, we know that the double bond between the two carbon atoms are breaking. The same thing will happen here. So when you have, for example, if you have two ethene units like that, right? So what happens is the double bond between the two carbon atoms will break. And these are the hydrogens. Okay, so you break the double bond in each monomer unit. After that, you can now combine them, right? So then it will result in a larger molecule called a polymer. So here I have just taken only 2 units, but in a polymer there are many units like adding up like this. So to represent the polymerization, I can use this form. So where you have n number of the monomers. So here as the monomer I have taken ethene. So then the polymerization happens where you break the double bond. So now in your polymer, so this unit, this is called the repeating unit of the polymer, will repeat n number of times. So that is your polymer. So the monomer is ethene. Ethene became what? Polyethene. You just add poly to the into the monomer's name. So it's just polyethene. So if your monomer is styrene, then your polymer will be polystyrene. Okay, so when we talk about polythene, so there are two main types called high density polythene and low density polythene. So what is the difference between these two forms? In high HDPE, which is the high density polythene, ethene molecules join in continuous chains with very small branches. That's how the ethene units join in continuous chains. And you can see here in this diagram, continuous chain, and you also have very small branches. Whereas in the low density polythene, LDPE, ethene molecules join to form highly branched chains like this. Now you have highly branched chains. So that will change the properties of high density and low density polythene. So because in high density polythene, the ethene molecules have only a very small amount of branches, right? So those molecules can pack closely. So close packing will result in high density, because it's taking a lower volume, and they are hard, right? So why they are hard? So if the molecules are packing closely, so they can have stronger dispersion forces, so that makes the molecule hard. And high melting point, so the same reason, the molecules pack closely, the strength of dispersion forces are higher, so therefore you should give more energy to break these dispersion forces in order to melt, so therefore high melting point. And they also have crystalline sections. When it comes to low density polythene, so because of the branches, the molecules cannot pack closely, so therefore the density is lower. And we say they are soft and flexible. The reason is the dispersion forces are weaker, so therefore the molecules can slide over each other very easily, so therefore they are relatively soft. And the low melting points, so because the dispersion forces are weaker, so with less energy, you can overcome them. So the melting point is lower, and we say they are non-crystalline. Okay, so what are thermoplastic and thermosetting polymers? So thermoplastic polymers, you can heat and reshaped, whereas thermosetting polymers, if you heat, they will decompose. So we'll see what's the reason for that. So polythene is a thermoplastic polymer. So we know in polythene, they have weak dispersion forces. So dispersion forces are weak, which means you can easily break the polymer. You can easily break the forces between the polymer chains. So we'll say, so these are the polymer chains, right? So between these polymer chains, there are weak dispersion forces. These are the dispersion forces. So you can easily break them. So therefore they will melt. So after breaking the dispersion forces, you can melt them. So in these polymers, there are weak interactions such as dispersion forces exist between the polymer chains. So these polymers can be heated and reshaped. So after breaking the dispersion forces, you can melt and then you can reshape. So example, polythene. But the thermosetting polymers are different because in thermosetting polymers, between the polymer chain, what you have is not dispersion forces. So there are strong cross-linking. So cross-links are stronger than dispersion forces. Now we'll look at a diagram now. So for thermosetting polymers, so these are the polymer chains. So now what we have between the polymer chain, so these are strong cross-links. So cross-links are covalent, they are covalent bonds, so they are stronger than the dispersion force. So when you apply heat, so using a small amount of heat, you can't break down the cross-links. So if you want to break down the cross-links, you should apply a large amount of energy. So that large amount of energy will break these cross-links, but not only the cross-links, it will also break down the polymer chains. So that's why the polymer is decomposing after heated. So you can't recycle these polymers, so you say, because they decompose when you heat them. So example, bakelite. Okay, now we will look at the factors affecting the properties of thermoplastic polymers. The first factor is the size of the polymer chain. So you can have longer polymer chains, the shorter one. If the chain is longer, they can make stronger dispersion forces. So therefore it results in tough material. Then the degree of branching, right? So you can have more branches or less branches. So if the degree of branching, the greater degree of branching result in low dense, soft and flexible material like in low density polythene, where you had greater degree of branching. So when the branching is more, what happens? The chains cannot come closer, so that result in weaker dispersion forces. So therefore, you can see soft and flexible material. And the nature of the side group. So the side groups present in polymers, you can have bulky side groups or small ones. If the side groups are bulky, so bulky side groups in the polymer, so you get low dense and brittle material. Why is that? So when the side group in the polymer chain is bulky, the side groups the chains cannot pack closely. So therefore, if the chains cannot pack closely, what happens? The density will be lower, right? Because it takes a larger volume then. And the brittle material, so when the side groups are larger, so what happens? That the chains cannot easily slide over each other. So that result in brittle material. And the next one is the arrangement of side groups. So when I talk about the arrangement of side groups, the side groups can arrange uniformly or randomly. If the side groups are arranged uniformly, this result in a stronger material. Why? When the side groups arrange uniformly, the chains can pack closely, resulting in stronger dispersion forces, therefore stronger material. And also the amount of cross-linking. So you can have occasional cross-links or you can have extensive cross-links. If the cross-linking is occasional, we get material like rubber, or we say elastic material. If the cross-linking is extensive, the material will be rigid and brittle. Okay, so that's the end of this lesson. So please do questions. You can find questions and summary notes on pages 71 to 76 from RoshChem 1 and 2 study guide. And thanks for watching my video. So you can, if you have any further, if you need any further information, please visit our website www.roshchem.com. Thank you. I will see you in another video.